Hello and welcome back to the lecture of time series econometrics. Continuing from the previous lecture, we are going to deal with the mathematical properties of AR and MA series of higher order. And in this lecture, we are specifically going to focus on the mean and variance of MA series of order 2. Now, when we deal with the MA series, first we'll write the standard form of MA series, which is YT is equal to epsilon t plus theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2. Let us first deal with the mean. Okay, so when we are actually dealing with the mean, what we do is we take expectation on both the sides, right? And we remember that like in AR2 process, here also we'll simply use the mean by assuming that the MA2 series is already stationary, right? So what we are going to do is we are going to take expectation on both the sides, so which will mean I have my E of YT is equal to E of my error term, which is nothing but 0. If my error terms are IID, theta 1 E minus 1 and theta 2 E of t minus 2, right? So, which will mean all these terms are going to be 0, right? So that means my expectation of YT is equal to 0, very simple. Now I can have a delta term, and in that case, if I have a delta, say here, if I add a delta, then my expectation of YT will be equal to delta. Now this value, just let me write down, if I have a, if I have a constant term delta in the series, okay? Now I can think of MA series which is of higher order, of nth order, or qth order. So in that case also, for a qth order MA series, if I do not have, let me write down for qth for qth order MA series, expectation of YT will be equal to 0 for no constant term, and will be will be and will be equal to delta for a constant term delta, if the series has a constant term delta. If series has a constant term delta. So you note that doesn't matter how many which order you take, it's always going to be delta. Okay, if we have a constant term delta. Okay, now we'll look into the variance of the MA series. Okay, now again simply we'll take expectation. It's really simple here actually. Let me write down the equation. The MA2 series first. YT equal to ET plus theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2, right? Now if I take expectation, if I take variance on both the sides, so which will mean var YT equal to is basically you take the variance of the whole term, but then when you multiply, when you take this product of et minus 1, et minus 1, et minus 2, or et minus 2, they're all going to cancel out, right? The covariance terms are going to cancel out. So what will be left is basically variance of et plus variance of theta 1 et minus 1 plus variance of theta 2 t minus 2, right? So now of course, I'll take theta 1, theta 2 out, and I will have all this, because they're IID, so I'll have all this value equal to sigma square plus theta 1 square, sigma square plus theta 2 square, sigma square. So if I take sigma square common, so I'll get sigma square 1 plus theta 1 square plus theta 2 square, right? So this is the variance, and I can also write using the notation of lag. I can also write is equal to, let me use a different color. It is basically here, this 0 is basically indicating the lag. 0 indicates lag. So the moment it is 0, you have variance. The moment it is more than 0, when you have lag 1, lag 2, they are going to be covariance. Now, if I extend this, MA series of higher order, so it can be of qth order, so then what will happen? It is going to be very simple, an extension of this model. So that means I will have, say, for, let me write down, for qth order, MA series, what I will have is variance of yt, var yt is going to be, very simply, you add all these terms, basically sigma square plus 1 plus sigma 1 square, theta 1 square plus theta 2 square, and so on up to, say, qth term, right? So theta q square, right? So that's about the mean and variance of MA series of higher order. In the next lecture, we're going to see the covariance of MA series of higher order.